carboxylic acids contain a carboxyl functional group attached to a hydrocarbon. Carboxyl groups contain both a carbonyl group, which is a carbon double bonded to an oxygen, and a hydroxyl group, an oxygen bonded to a hydrogen, that are connected to each other and the hydrocarbon, or the alkyl group, as shown here. The carboxyl group is highlighted in red.
We write the general form of a carboxylic acid molecule using the letter R in the general structures to represent either a hydrocarbon alkyl group part, a hydrogen atom, or any other organic group of atoms.
In an esterification reaction, a carboxylic acid reacts with alcohol to produce an ester and water. This reaction is very important, involving the storage and metabolism of fat, also known as triglycerides, and in other biological processes. In an esterification reaction involving a carboxylic acid and an alcohol, water is produced and also an ester, and the way an ester is formed is by the R groups from the carboxylic acid and the alcohol come together on the carbonyl group, as seen here, and form an ester with two oxygens here, and the water comes off from the carboxylic acid, the hydroxide group here, the oxygen and the hydrogen, and the hydrogen comes off from the alcohol to form water and the products.
An example of esterification would be propanoic acid, ethyl alcohol coming together to form ethyl propanoate and water. The two hydrocarbon groups come together on the carbonyl group, and the OH and H come together to form water. In nature, ethyl propanoate is found in small amounts in some fruits and gives off a pineapple-like scent.
So now that you understand how esterification reactions work with carboxylic acids, we can now use pentanoic acid and propanol, and we want you to figure out the products. Click pause and work on the problem.
So the products you should have gotten from the reaction with pentanoic acid and propanol is propyl pentanoate and water. The hydrocarbon group from pentanoic acid and the hydrocarbon group from propanol should have come together on the carbonyl group, and the OH and the H come together to form water.
If this reaction is ever done in a lab with a carboxylic acid and an alcohol, a strong acid catalyst can be used, such as H3O.